have the motion of a body which is at rest, we need to apply a force either in the form of push or in the form of pull, and of course, there may be non-contact forces. Similarly, if a body is in motion and we want to bring it to rest, we need to apply a force. Once again, I am doing this exercise. This body is falling under the force of gravity along this inclined plane, and during its motion, if we want to stop it, we need to apply a force. So, these are the exercises we are very much familiar with. Now, what are the forces really acting on a body like this box when it is kept on the table? Is it only the push and pull when I apply them come into play only over this box, or does it already under the influence of one or more forces? When this box is kept over this table, its weight is acting in the downward direction. That weight is essentially the pull of gravity on this box. Naturally, the question comes, why does not the box move further towards the earth? Or in other words, is there some additional forces apart from its weight that are playing some role? Please take a look at this exercise. When you drop this box, it really comes down under the influence of gravity. You can always see it is falling down under the force of gravity. But here, when I keep it, it does not fall down. Actually, when this box is here, another force comes into play which is equal and opposite to its weight, and these two forces balance each other and the box remains stationary. So, when this box is stationary, the situation is like this. This is the surface of the table, this is the box, and this is the weight of the box, and this is normal reaction which is equal and opposite to the weight of the box. As a result, we observe this box to be stationary over here. Interestingly, this normal reaction is a self-adjusting force. By self-adjusting, we mean that it provides the necessary amount of force depending on the weight of the body. For example, this cap of the pen is much lighter than the box, this box, but this one is also resting on the table. That means its weight is acting on the table in the downward direction, and it has got exactly equal and opposite amount of force in the upward direction. So, the table is in a way very intelligent. It can provide the necessary normal reaction to the bodies depending on their weight. Had it offered larger amount of normal reaction as it has offered in this case, this cap of pen would have flown off from the table. On the other hand, the smaller normal reaction, had that normal reaction be available to this box would have been able to go downward further, possibly by breaking the table. So, normal reaction is a self-adjusting force depending on the weight of the body. When we apply any additional force on this box to make it move, like push or pull, we are basically applying some additional forces to have this motion. That means, the box was under the influence of two forces, two balance forces, and it was stationary. Now, I have applied an additional force and it has started moving. So, we can feel that if a body is under some forces and if those forces are balanced, in spite of having the forces acting on the body cannot move, it cannot have any motion. So, the stationary body over here remains stationary under the influence of two forces. One is its weight, another is normal reaction. It starts moving only when some unbalanced force like this push or maybe the pull that starts coming. Now, suppose I pick up this box and I am applying. Now, suppose I apply equal and opposite pushes on this box from the two sides. Naturally, it cannot move. Once again, all the forces acting on this box are balanced. But anything else do you expect to happen in this case? I think we can show it if we take a ball and undertake the similar exercise. Let us take this ball. This one is made of a soft material. I keep it on the table. As it happens, if I really give it a small push, it starts moving. It starts moving very easily. Now, suppose I pick it up and really make or suppose I really give the push, equal pushes from both the sides. Does it move? Answer is no, it does not move, because once again it is under the influence of four balanced forces. I mean, two pair of mutually balancing forces. Once again, its weight is there, normal reaction is acting in the upward direction, and my left palm is pushing it towards right, and equal push has been provided by my right palm towards left. But is that the whole story? Possibly not. Take a closer look. You will find that the ball is getting deformed. Ball is no more is in its own spherical shape. It is getting deformed. And once we remove these forces, the ball gets back its good old shape. Of course, that may not happen always. For example, if you really take a dough of flour and do the similar exercise, you will find once you have removed the external forces, that remains deformed. So, we can understand two very well known things, well observed things in this way. Number one, the balance forces really do not produce any motion, but they can give rise to deformation of the body. Number two, this deformation may not be always perceptible, because that depends on the nature of the substance and the magnitude of the force applied over there. But in some of the situations, and if the force is within certain limit, if we remove the forces, that deformation goes off, and in some cases it does not. Now, that opens up the study of another set of properties of materials. These are known as the elastic properties of the materials. A very well known experience that virtually all of us are having is the stretching of a rubber band. This is a rubber band, very familiar one. Now, if we really stretch this rubber band from the two sides equally, you can see there is no net motion of the rubber band, but it has got stretched, it has got elongated. Now, if we release this pull, it comes back to the old shape and size. So, it gets back the old shape and size. So, by applying balance forces, those are equal and opposite, we can have deformation. By applying unbalanced forces, we can have motion. So, we must understand that when we are looking at a body which is stationary, we have to appreciate that there may be number of forces acting on this body, but ultimately all these forces are balanced and they are balancing each other. On the other hand, if we see a particular body is in motion, then, and of course, under the influence of the balance force, a material has got deformation, however small that may be. It may not be perceptible by our eyes, but some deformation has taken place, as I have already mentioned, depending on the nature of the object and the extent of the applied force. A body under uniform motion also under the influence of balanced forces. In conclusion, we can say that unbalanced forces can produce motion or can bring about change in the motion, but balanced forces produce deformation in the body, and on removal of the balanced forces, the body may or may not get back its shape and size. Thank you.